Lesson 31, we are talking about derivatives. Okay. Before we talk about that rule up there, look at example 1. Y equals x squared sine x, and they're asking us to find y prime. So they're asking us to find the derivative. What kind of thoughts do you have there? Okay, the derivative of x squared is 2x, yes? The derivative of sine x is cosine x. Now, so what did we have to do there? There wasn't just one derivative, there were 2 derivatives. And that's kind of a warning sign that we have to use. In this case, it's the product rule. Okay, so backtrack a moment. Because my answer is not x squared my answer is not 2x cosine x. Okay, there's a little trick to it here. But what I want you to think, because as we go through this, like, as you go through problems down the road and stuff, it's really easy to forget the product rule and just do what we just did. Okay, 2x cosine x, my answer is 2x cosine x. But if you're taking those 2 derivatives, we have to use something called the product rule. So the idea of the product rule is when you have 2 items that are being multiplied together that we need to take the derivative of, we need to do as such. So if we're taking the derivative of f times g, where f is one part and g is the other part, derivative of f times g plus derivative of g times f. So the idea of what we're doing here is we're taking the derivative of each, but you take turns in doing that. So the first time through, we take the derivative of one of the pieces. Keep that other piece the same. And then add, and then reverse the process. Take the derivative of the other piece, keep the other, then whatever other piece there is the same. That probably sounded really confusing just now, I realize. Yeah. Let's put it into play, okay? We already talked about example 1, in that there's an x squared and a sine x, yes? There's 2 pieces. So what I'm going to ask us to do is to think of one of these as f, and think of the other one as g. Okay, so if I think of x squared as my f and sine x as my g, okay, in order to find y prime, notice what it said at first, the derivative of f times just regular g. So what is the derivative of f? What is the derivative of x squared? 2x times g, which that means keep g as is. So that's the f prime g. Then it's plus. We're always adding when it's product rule. Now reverse the process. Take the derivative of the opposite piece and keep the other one. So now I'm going to take the derivative, and I don't know which way you want to think about it. Up there it reads, take the derivative of sine x, which is cosine x, and then you're keeping the x squared. So you could write it as cosine x times x squared. I wouldn't recommend leaving it like that because that kind of brings the question of what it's cosine of what. But that's the idea. When I clean this up, really about the only cleanup I can do is switch that back piece. I can say that this is 2x sine x plus x squared cosine x. The other option, and I won't always write this, but I'm going to on the first time. Does it matter what order I add in? No. So the other option is I could say that this is x squared cosine x plus 2x sine x. And I write that down just to point out that when you have 2 pieces multiplied, does it matter which piece you take the derivative of the first time through? No. You take the derivative of one, keep the other. Plus, and then you flip it. So derivative of the opposite one and keep the other. Okay, so product rule. It's an incredibly important rule to remember, because if you just take the derivative of the 2 pieces and stick them together, you've totally taken the derivative wrong. Okay? Questions? That's the short of it today. I mean, we're going to look at some special cases and some ways you can express final answers, but we will talk about differentials down there a little bit, so we'll review those a little bit. Okay, let's look at example 2 then. If f of x equals x squared e to the x, find f prime of x. Okay, so what do you want to do? Okay, derivative of x squared is 2x, and then we keep e to the x. The sign I write here is a plus sign. What do I do this time through? Yeah, we're keeping the x squared this time, but taking the derivative of e to the x. What's the derivative of e to the x? It's itself, right? E to the x. That was one we learned before break. Now, ways to write this. Technically, one way to write it is pretty much as it is, yes? Where we could write 2x e to the x plus x squared e to the x. Another way to write this, which you will often see, is they will factor out a GCF. What GCF do I have between those two terms? An e to the x, and technically an x, yes? And so another way to write this is x e to the x. If I factor out x e to the x, what remains on the first term? 2. Plus, if I factor out x e to the x, what remains on the second term? X. Not x squared, but okay. If we get technical, both answers are correct, yes? Okay. Realize when we're grading against the book answer key, I'm looking for some correct form. A good portion of AP is being able to recognize that, okay, this is my answer, that's that answer, that's equivalent, because that's what they'll do on AP testing. They'll look for equivalence. And that's what you guys need to be able to do on the multiple choice portion. If they give you an easy problem like that that says take the derivative, you've got to realize, well, maybe they'll give the answer in that form. Maybe they'll give the answer in that form. Okay. Let u equal ln x, v equal 2e to the x, and y equals uv. Find y prime. There's a couple different ways we can do this. So I'm curious, as you look at the problem, if you have any thoughts. Rewrite the problem?
Start with y prime.
What did you mean by rewrite the problem?
As in plug everything in and then rewrite it like the first two problems are.
Okay. Is that an option? Okay. If it says y equals uv and they tell me what u and v are, could we go ahead and write that out? And that y is equal to, let's see if it's uv, it's what? ln x times 2e to the x? I think I'd almost like the other order better, really. But in all honesty, it's not going to matter. The other order would have been to say 2e to the x ln x. Because then you don't necessarily have to have the multiplication out there. But, okay, you guys ready to take the derivative? Y prime. If I go with this version over here, 2e to the x ln x, and we could go with either one. Okay, what's the derivative of 2e to the x? 2e to the x, right? Times, what do I do with ln x? I keep it as is. Next we have a plus. And what do I do this time? Keep the 2e to the x this time, times, do you remember what the derivative of ln x is? 1 over x. Thoughts on how I could write this out?
Take the GCF of 2e to the x.
Okay. Could we do a GCF here? We can. Again, technically you don't necessarily have to, but recognize the equivalent form. So if I factor out a 2e to the x, what remains? ln x plus 1 over x.
Never.
Might be construction equipment outside. I hear something, or I did. Okay. It's coming from this corner of the room. Okay. Example 4. Let f of x equal e to the x cosine x. Determine f prime of 1.2. So what do I need to do first?
Just ignore the 1.2.
Find the derivative, yes? After we find the derivative, then what? Plug the 1.2 in. Okay, but you can't plug the 1.2 in. Anytime they ask for the derivative at a certain point, don't plug that point in until you find the derivative. So start by finding f prime of x. Okay, first part. Okay. The derivative of e to the x is e to the x. So what do I do with cosine x? You keep it cosine x. Plus, next time we're going to keep e to the x. And what's derivative of cosine x? Negative sine x. How could I clean that up? You can put a GCF of e to the x. So it's e to the x times cosine x plus negative sine x, or I'm actually going to write minus sine x. What did this problem actually ask me to do? Plug in the 1.2. So f prime of 1.2 is e to the 1.2 times cosine of 1.2 minus sine of 1.2. How are you going to find that answer? That is a calculator problem. You got the same answer I did? What's an appropriate way to write that answer? Okay, 4 decimal places. AP test, minimum 3. You do anything under 3, you're not going to get full credit.
What if you didn't
Do
want
they have a preference or just minimum?
Officially, it's 3.
would they put
What will happen is if you do more than 3, they will only grade 3. Okay? So you need to be in the habit of, when it comes to AP testing, best habit is to be doing 3. I can't remember.
Doesn't the book want 4?
The book asks for 4, which is why I'm flexible in the book when we say 4, that if you only do 3, I get it. Because,
Well, if they're only grading 3, then wouldn't you just need to make sure that it's 3? Because if you do 4, then you might not round that.
well, and that's where I'm trying to remember how, I forget how it works, if that next digit would round it. And that's what I can't remember. I'll have to ask. I have an AP Calc conference in November. I'll have to ask because I can't remember how that works. Okay, so if I go 4 decimal places, negative 1.8914. If it's 3 decimal places, negative 1.891. Either way, you would get the same credit in that case, for sure.
So what if it's like the answer that you get on a calculator is 1.2? Would you just put 1.200?
Okay, in that case, you don't have to have, if it stops at 1 or 2 decimal places, you don't have to have, right.
It's just a freaking whole number.
No, you do not have to say a whole number of 2 is 2.000. No, that's not what I'm saying. But if it's more than 3, you know, if you've got a dig along your rational decimal on your calculator screen, round it down. Okay, example 5. Throws in differentials, if you recall those. Okay, s equals x squared y cubed. Find ds. Trying to remember which way I want to teach this. What did I teach?
This is the one with the X, Y values.
This one covers us, but it's maintenance.
It's not my shirt. I smell.
Okay, so at the time, and so I'm going to teach it slightly different this time, based on the fact, I was just trying to remember what I taught previously, based on the fact that we have 2 variables here. Okay, we're trying to find ds, but we have an x and a y in the problem. It'd be a slightly different idea if this was either all x or all y. When we brief review here, do you guys remember doing differentials before break? If we were asked to find dy, traditionally I had you guys start by finding dy dx, which just means finding the derivatives here, because it's y, and all those are x's. But then to get rid of the dx, we multiplied it over to the other side. Does that sound a little familiar?
Yeah.
Okay, now, a different way to do this problem, this is what I'm going to teach here, is that if we skip these 2 rows here, okay, ignore those middle 2 rows, but think of in terms of the derivative of y is dy. The derivative of 3x to the negative 2. Well, it's still the negative 6x to the negative 3, but what variable is that? That's an x. So with respect to x, it's a dx. Derivative of 2x squared is still 4x. With respect to x is a dx. Derivative of 1 is still 0 and gone. The difference in this problem is if we're taking the derivative of x, we're going to tag on a dx. If you're going to take the derivative of a y, you tag on a dy. Do you see where I'm going with this? So let's look at this example. S equals x squared y cubed. They want us to